We left off last time at the very beginning of this problem, which was to find the length of the asteroid. And it looks like that. It's actually rather cool. It is traversed counterclockwise. And we want to find the length of it. And so one of the things that we realize is to find the length of it, we don't have to worry about all four pieces because we can assume it's symmetric. So I'm going to find the length of one piece and then multiply it by 4. All right, so I'm going to just find the length of the blue piece first. And we already know that the length formula, the integral from A to B, square root of x prime of t squared plus y prime of t squared dt. So let's find x prime of t. So we're going to get 3 times the cosine squared of t, and the derivative is going to give me a sine t. And then if I square that, I'm going to get 9, the cosine to the 4th of t, times the sine squared of t. Now I'm going to find y prime of t. And that's going to be 3 times, and I have a negative missing. Negative sine t. Okay, there we go. So 3 times the sine squared of t, and the derivative is the cosine of t. And when I square that, I get y prime of t, quantity squared. It's going to give me 9 times the sine to the 4th of t times the cosine squared of t. So the square root of x prime of t squared, well, let's just do x prime of t squared. X prime of t squared plus y prime of t squared. So that's 9 times the cosine to the 4th of t times the sine squared of t plus 9 times the sine to the 4th of t times the cosine squared of t. And let's simplify that. Let's pull out a 9. We can pull out a cosine squared t, and we can pull out a sine squared t. And in that first piece, that's just going to give us cosine squared t. And in that second piece, that's going to give us sine squared t. And how beautiful is that? Because this is just equal to 1. So therefore, when I go to take the square root of x prime of t squared plus y prime of t squared, I'm only taking the square root of 9 times the cosine squared of t times the sine squared of t. Now, when you take the square root of something squared, that gives you absolute value. So this is going to give me 3 times the absolute value of the cosine of t times the absolute value of the sine of t. So now let's put it back. So L is the integral. Now we're only going 1/4 the way around. So we're going to pi over 2. So that's 0 to pi over 2. And then we get 3 times the absolute value of the cosine of t and the absolute value of sine of t dt. But life is good because on the interval 0 pi over 2, the cosine of t and the sine of t are both greater than or equal to 0. So I can drop the absolute value. So this now becomes the integral from 0 to pi over 2 of 3 times the cosine of t times the sine of t dt. Now you can integrate this many different ways. The way it doesn't, oh, do I have cosine of pi over 3? That's wrong. That should be pi over 2. So there's several different ways that you can do this. You can let u be cosine, du be sine. You can let u be sine, du be cosine, or you could say that the cosine of t times the sine of t is 1/2 the sine of 2t. There's so many ways to integrate this. So I'm going to integrate it this way and just make this 3/2 the integral from 0 to pi over 2 of the sine of 2t dt. So I get 3 over 2. And then when I integrate that, the integral of the sine of 2t becomes minus 1/2 the cosine of 2t. And then I'm going to evaluate that between 0 and pi over 2. So that's going to give me negative 3 over 4. And then when I do the cosine of pi, I'm going to get minus 1. And then I'm going to get the cosine of 0, and that's also going to give me a minus 1. So when I multiply that whole thing out, I get 3/2. So now we can conclude that the length of the asteroid on the interval 0 to 2 pi is going to be 4 times 3/2. So we're going to get 6. Okay. I don't think we can do the area of this one because I don't think I've taught you. What's calc? This is calc what? 3? Oh yeah, it's calc 3. We can do that. Calc 3, you can do it. Okay, so let's find the area underneath that one little piece. So let's go back and find the area enclosed by the asteroid. And again, C is x of t is equal to the cosine cubed of t, and y of t is the sine cubed of t, and t between 0 and 2 pi. So I'm going to go back up here only because I am really particular about stuff. You guys can just put it in your notes, however. But I'm just going to copy this picture and copy it. And then bring this picture right on down here. And paste it. So what I now want is this area. Okay. So again, we're going to use the fact that it's symmetric. So we're only going to compute the area underneath the first piece. Okay. So we know that our area in general is the integral from A to B of f of x, which is y, dx. And we already converted this to the integral. Now we don't know whether or not we're going to have A or B. I'm sorry, alpha or beta. Hi, Amaya.
Oh, hi, it's Anaya. I just joined from my laptop. I'm sorry.
Okay. All right.
Just switched the
I'm like, I'm a little confused, but thanks. Okay. All right. So y, we know then this just becomes y of t. And this becomes x prime of t dt. So we're just going to put it in as such. Okay. So now here's the thing. Am I going from the integral from A to B or the integral from B to A? So how do we check this? Okay, so we need to check. So first off, we have the, x, which is f of t, is the cosine cubed of t. Okay. So f of alpha is f of 0, and that is 1. And f of pi over 2 is f of beta. Oh, I wrote that backwards. F of beta is f of pi over 2, and that's 0. So now if you remember, if f of alpha is less than f of beta, we do alpha the beta. But if f of beta is less than f of alpha, we do beta to alpha. Okay, so since f of beta is less than f of alpha, and that's pretty easy to see. Our curve is going in this direction. So if we try to compute the area, it's going to be negative. So we're going to do the integral from beta to alpha. So we're going to do the integral from pi over 2 to 0. And then for y of t, we're going to put cosine cubed. And for dx dt, y of t is sine. Y of t is sine cubed of t. And then for dx dt, we're going to get 3 times the cosine squared of t times the sine squared of t. That is wrong. 3 cosine squared t times the sine of t. Oh, Dawn, why did you pick such a hideous function? Oh, well, you picked it. Let's do it. So I get the integral from pi over 2 to 0. I have 3 I'm going to get sine to the fourth of t times cosine squared of t dt. How do I integrate that? That's a Calc 2 question. Okay, this is actually pretty hideous problem, but the way you integrate it is I'm going to change the sine squared of t to be 1/2 times 1 minus the cosine of 2t, and the cosine squared of t to be 1/2 times 1 plus the cosine of 2t. So that's what you do when they're both even. So I get the integral from from pi over 2 to 0, and this 3, and then I'm going to get 1/2 times 1 minus the cosine of 2t, but that whole thing has to be, that's sine squared, so that has to be squared, and then I get 1 plus the cosine 2t, and I'm missing 1/2. Okay, so I have 3, 1/2 squared is 1/4 times 1/2, so I'm going to get 3/8, the integral from pi over 2 to 0, and now I'm going to get 1 minus 2 cosine of 2t plus cosine squared of 2t times 1 plus the cosine of 2t. Oh, this is a bear. We're not going to finish this right now because I'll be here all day. This is 3/8, the integral from 0 to pi over 2 to 0. Actually, why don't I just, I'm tired of that. Let's put a negative in front. Negative the integral from 0 to pi over 2. Okay, there we go. So now I'm going to get 1 minus 2 cosine 2t plus cosine squared of 2t. And then I'm going to get a cosine 2t, a minus 2 cosine squared 2t, and then a cosine cubed of 2t dt. Okay, this will take up more time than I have. So I am going to quickly find the answer, and then you guys can verify it. Whew. So what is the integral? It's the integral, I got to remember. The integral of, or the original integral was minus 3, the integral from 0 to pi over t. Sine of x to the 4th, right? And then it's the integral from 0 to pi over, from pi over 2, from 0 to pi over 2. Okay, it's 3 pi over 32. Okay, so therefore, I can conclude that the area inside the asteroid is 4 times that. So that becomes 3 pi over 8. Now, I'll be honest with you, I need to double check that answer. So I will double check that answer and make sure that that is correct. Okay, the only thing I'm concerned about is the integration because I did it so fast. Okay, so, and I mean, I did it quickly. So I'll have to check that. Okay. Let's look at another problem. So we've done a length and an area. Length, area. And that's where I made a mistake. I see it there. My mistake is here. Go back. There should be a negative there. When I took the derivative of the cosine, I threw away my negative. So there should be a negative here. And then there should be a negative here. And then there should be a negative here. And so when I flip it, there is no negative. Okay. Now we're good. All right, now I feel better about that answer. Okay, this one's a weird one, but it works out really nice. It's actually rather easy. Okay, so we want to use a parameterization of a circle. So say we have, so this is example. All right, so here's the curve. It is x is equal to cosine of t. Y is equal to sine t. 0 less than t less than 2 pi. So we already know that this is a circle of radius 1. So parameterization of a circle of radius r equal to 1. Okay. So what I want to do is I have this circle. So I have this circle. Let me see if I can get a good circle here. Nice circle. So I have this circle and I want to rotate it around the x-axis. And create. So I'm going to rotate this thing around the x-axis. And I'm creating kind of like, looks more like something like this, but it's pinched in the middle. Okay, but it's sideways. So let me see if I can draw that. So that kind of looks like this. So what it turns out to be is something that looks like this, but it's pinched in the middle because all of it, it's yeah, there we go. That's what it looks like. Yay. Okay, so I want to find the surface area. So we want to find the surface area of the resulting solid. Okay, so this thing is rotated about the x-axis. So our Cartesian formula, if we remember, was the area, sorry, the surface area. I think I called it A, but surface area. It's the integral from A to B of 2 pi times y times the square root of 1 plus y prime squared dx. But we already changed this. So we said that this is equal to the integral from alpha to beta of 2 pi y of t times the square root of x prime of t squared plus y prime of t squared dt. Okay. All right, so what do we have? Well, the first part is easy. We already know what x and y are, so we need to find x prime of t. Derivative cosine is minus sine of t. and y prime of t, derivative of sine of t is positive cosine of t. So therefore, the square root of x prime of t squared plus y prime of t squared is the square root of minus sine of t squared plus positive cosine of t squared. So that becomes the square root of the sine squared of t plus the cosine squared of t. And yay, something easy. That's the square root of 1, so that's 1. So that whole big square root just becomes 1 for us. Uh-oh, I made a mistake. Y, I'm sorry, guys, reading my notes. Y is not sine t. Y has to be 1 plus sine t. Otherwise, it would be centered at the origin. I want this thing centered up top here. I want it centered up here. I don't want it centered at the origin. So this is 1 plus sine t. And I knew something looked weird. In the next section, you will see why it is 1 plus sine t. This is a circle of radius 1 with the center being 0, 1. Okay. All right, now it makes more sense. Because when the other one would have been a circle of radius 0, no, a circle centered at 0, 0, and that's not what I want. I want the circle up top, and I want it to go all the way down and come back. So now it is correct. All right, so let's see, does that change anything? I don't think it changes anything. Y prime is still just cosine t. All right, but it does change it here, which is how I found my mistake. So I get my surface area is the integral alpha is 0 and beta is 2 pi. I have 2 pi. Y is 1 plus sine t. Then the square root of x prime of t plus y prime of t is just 1. So the only thing I get left is dt. And I get a very nice, very easy integral. Okay, nothing like that long one from the before, which I will go back and fill in all the steps. Okay. This is easy to integrate. We're going to pull the 2 pi out. I'm going to integrate 1 and I'm going to get t. And I'm going to integrate sine t. And I'm going to get minus cosine of t, evaluate between 0 and 2 pi. And when you do everything, you simply just get 4 pi squared. Okay, any questions about that? All right, let me see. Any other examples that I have? Did anybody try the homework and have a problem that they're stuck on?
Yes, I did.
Okay. have time left and from my example, so I'd like to do whatever it is that you have questions on. So what might that be?
For homework 1.1.
Okay, whoa, I think I have three people talking at one time. Oh, actually one person, Stephanie, you just have an echo. Can you do it again?
Yeah, so homework 1.1, can you hear me?
Y'all are together. Well, all right then. Okay, go ahead. That's why I hear an echo. Okay, go ahead.
Okay, so for homework 1.1, one of the questions asked about vector parameterization.
Okay, so yes, I did realize that, so let me just explain to you what that means, and I apologize that problem got in there. When we're going to talk about vectors in a moment, but when we talk about, there's a way to define a curve in terms of a vector. So when you have the vector parameterization R of t, it is x of ti. Well, x of t, it's a vector, so you can write it as x of t, y of t, and if there's a third part in 3D, it would be x of t, y of t, z of t. But we're not talking about this yet. So I took out anything that definitely had a z of t. So you shouldn't have any problems with that. Am I right?
I did the homework a few days ago, so it was still there for me, but it might be different now.
Can you tell me what the problem is?
Yeah. It was asking me to find the vector parameterization of the curve x equals -5z squared in
It
the
says x is equal to,
-5z squared. And it was in the xz plane.
That's the same problem I had. It's on 1.1, the first
yeah,
problem.
it shouldn't be there. Okay, so yeah, it shouldn't be there. Okay,
It's
so in the XZ plane, let me go back and take that problem off, because I'm going to have to go through too much that we haven't gotten through yet to get there.
Okay.
Yeah, that problem shouldn't be there. That problem was taken from another professor who put it on his homework, and I should have not allowed that problem to be on there, because that problem's a little tough. We haven't gotten to vector parameterizations yet. So, okay. Any other problems, or everything else okay?
Yeah, that was the only one that really stuck out to me so far. That I was like,
Yeah. Naya?
I will probably have more questions tomorrow.
Okay, what was your question?
I didn't have any questions.
Oh, you didn't have any questions.
No, I said I'll probably have questions tomorrow.
Oh, you'll have questions tomorrow. Okay,
Yeah.
well, let me see if I can find a problem just that might help you right now.
Oh, actually, I have another question.
Is your question?
In the 1.2 homework, it gave a it said find the area of the region enclosed by a parametric function.
Can you speak up just a little bit?
Yeah. It said find the area enclosed of a parametric function.
Yes.
And I was wondering if there was a way to like find the point of intersection without graphing the function.
Okay, so can you give me the curve, please?
Yes, so it was x equals p cubed
X is equal to t cubed.
minus 7t,
Okay.
and then y was equal to 6t squared.
Okay, so that's the curve. And then did they give you what t went from?
No, so you were supposed to figure out the limits of integration.
So you have to figure out the limits of integration.
To then find the area.
Okay. If I set these equal, I get when x and y are equal. I'm trying to think how I would find the limits of integration here. So if I have t cubed minus 7t equals 6t squared, then that would give me t cubed minus 6t squared minus 7t would equal 0. So that gives me t times t squared minus 6t minus 7 equals 0. So I get t times t plus 1 times t minus 7 equals 0. So now I get t is equal to -1, 0, and 7. Now, what does that do for me? So when t is 0, x and y are both 0. When t is 1, x and y are both, t is -1, x and y are both 6. At t equal to -1, x and y are both 6. And at t equal to 7, x and y are both 6 times 49. Now I'm trying to figure out what that does for me. And so the question says, find the area
Yeah, so the big curve looks like. Well, it's the area of the enclosed region.
What is the area of what?
The enclosed region,
And I had to find the limits of integration.
it like in the example or like the practice similar, it said that you could graph it and find where they intersect and do it that way. I was just wondering if there was a way to do it without graphing.
I can't think of a way to do it without graphing it. That's what I'm trying to see.
Okay.
Is there a way to do it without graphing? I can't really see how to do it without graphing.
Okay.
Here's a good problem. Yeah, I can't see how to do that without graphing at this moment.
Thank you.
Find the tangent line. to the curve C, where x is equal to the secant of t, y is equal to the tangent of t, and minus pi over 2 is less than t is less than pi over 2 at the point square root of 2, 1, which is where t is actually equal to pi over 4. Okay, so I want to find the actual the tangent line. So I give you the point on the Cartesian curve, square root of 2, 1, and it's at that point when t is equal to pi over 4. So how do you find the slope? So in order to find the equation of the line, what do I need? Well, I just told you the answer. We need a point and the slope. We call m. So we get y minus y1 is equal to m times x minus x1. But m, the slope, is just the derivative of the curve. So we need to find dy dx. How do we find dy dx? Find dy dt divided by dx dt. So what's dy dt? What's the derivative of tangent of t? That's an easy one. Are you looking for it, Stephanie? It's okay. It's okay. It's all right.
I have the guide though, so
Okay. Oh, you got the guide. Isn't it wonderful?
it is. I love that
I
guide.
told
Where did
you.
you get it from? You went to the bookstore?
Yeah, the bookstore.
All right, I don't need to get it.
I told you that thing is wonderful. Okay, so the derivative of the tangent is secant squared. Good. And then the derivative of the secant is,
Secant x times tan x.
okay, so secant t tangent t. All right, so I can divide out the secants and get secant t divided by tangent t. Okay, so now what's the secant of pi over 4? That's 1 over the cosine of pi over 4. That's on that little table too. Anaya, you got to get with it. Get that
I know
table.
I was gonna get it. I was gonna get everything this weekend.
Okay.
So the secant, so you flip that.
So secant of pi over 4.
Would be 2 over the square root of 2.
That's right, which is the square root of 2. And the tangent of pi over 4 is 1. So there you go. We didn't even find the actual Cartesian form of the curve, but we found its derivative. We found its slope. Okay, so therefore I get y minus y1, which is 1 is equal to m, which is the square root of 2, times x minus the square root of 2. So I get y minus 1 is equal to the square root of 2 times x minus 2. So therefore y is the square root of 2 times x plus 1.
Isn't it -1?
It is minus 1. I said, I can't circle that, something feels wrong. Okay, so the answers to your guys' questions that I did not answer, I will have for you tomorrow. This one's interesting. How do you do that without graphing? Because the only time it's there, x is 0 and or y is 0. Yeah, I have to think about that one. Okay.